Konnichiwa, kyukum komenasai. I'm very excited to be here. Welcome to the Prometheus maintainer section. And if we're going to be spending the next 30 minutes together, we might as well just get to know each other a little bit better, right? Josue, or Josh, commonly known as God Josh online. When I'm not coding, I'm usually snowboarding, which wasn't the easy sport to catch on, given I actually come from a place called the Dominican Republic in the Caribbean. I'm currently based in London, right? And one of my dreams is to eventually snowboard one of the most beautiful mountains in the world, with Niseko. I'm in the wrong time to be able to do that right now, but hopefully, you know, when winter comes around, I might be able to come back and spend some time over there. I'm a software engineer that's part of the metrics team at Grafana. For the past 3 years, I actually led the alerting team at Grafana, which is the title I'm trying to shake off very, very badly right now. I'm internally known as the alerting guy. I don't want to be known like that anymore. Don't call me that. Don't ask me alerting questions. I'm joking. You can ask me any alerting questions. I love it. But yeah, I'm now working in the next generation of metrics and the architecture that we're trying to put together at Grafana. I'm also a Prometheus maintainer. That's why I'm here. And my primary role within the Prometheus community is taking care of the alert manager. But I also try and do as much as I can within Prometheus and its rule engines and other parts of it. Cool. So before we even begin, I want to get a sense of where the room is at. So let's do a little bit of a show of hands to see where we are. Who here is familiar with what Prometheus is or what it does? Okay, a good chunk of the room. Who here has actually tried Prometheus? It's like you have installed Prometheus, you've actually worked with it. Cool. Who is actually using it in production today? Oh, lots of hands. Great. Love it. Love to see it. Love to see it. We have a good mixture of people that are expert, people that have never tried it before. So hopefully this talk would bring something for everyone. So I want to begin with a little bit of history, right? Prometheus originally started at SoundCloud. It's not something that many people know. When a bunch of ex-Googlers, such as like Julia, Matt Proud, and Bjorn, joined the company due to a bunch of reliability issues that they had. If you haven't watched the documentary of Prometheus, which the good people at Honey put together, I suggest you watch it. You can scan this QR code. You can watch it while you have dinner tonight or something. It's great. It's amazing. Being able to see the history of a software unravel and people tell you firsthand why they created this thing that everyone uses today, right? It's something almost magical to a certain extent. The documentary is meant to give you like a wider lens on why we got here and why Prometheus exists, and I just think that's really cool, right? Moving on, Prometheus joined the CNCF back in 2016. It was the second project ever, right? The first one being obviously Kubernetes. And as you know, like there's a match made in heaven between those two, right? Like Kubernetes immediately adopted the Prometheus metric model. And it turned out to be the de facto standard of monitoring for anyone that was using Kubernetes. Then in 2017, we released version 2.0. The main highlight of that version was the internal database that changed. So we have changed the format, we have changed the way that it works, and it served as the foundation of success for the project for the next decade, almost a decade, I would say, right? And just to give you a story of some numbers over here, you can see these numbers are provided generally by Grafana, right? And this tells you the number of active Prometheus data sources should the person opt out to enable reporting. So this is basically the number of active instances we have right now of Prometheus running. I only have the number for 2024. I couldn't find the number for 2025, but it should be a little bit more than what you see over there, of course, right? What I want to highlight with that is that Prometheus continues to be adopted at a very steady pace, and it's a very healthy project, right? Cool. So what is Prometheus, for those that don't know, is basically a metrics-based monitoring and alerting stack. We have a very rich instrumentation system for all kinds of applications and systems in what we know as the exporters. Prometheus is itself in charge of doing all the metric collection and storage. And once it's actually stored, you can do all the cool things that you hear about, like querying, alerting, or building dashboards on top of it. One of the really cool things about the exporters is that they go across all levels of the stack, right? So you can find an exporter for system D as you can find an exporter for the database that you're using, right? And anywhere in between, right? Yeah, if it's not something, if an exporter has not been created yet, it's like you can create one in seconds. And it was designed from the ground up to handle dynamic cloud environments. We're here at a Cloud Native conference, and this was ingrained into the design of Prometheus, being able to handle what we call series churns very, very well. So this is like things going up and down regularly as you kill new pods and spin new pods all around. Cool, that's good, all that, but in theory, right, like, how does this actually work, right? So first, on the left, we have what we call targets, and targets can be anything, right? We're talking about your web-based application, we're talking about your API, which you would use the client libraries in order to be able to instrument them. We're talking about your VM information or the machine where it's running, if you're running something like Node Exporter, or the database itself, such as the MySQL exporter, right? So the idea is that you can get metrics from all levels of the stack, right? And then Prometheus will go ahead and grab them. This is what we call the pool-based model, so you don't have something pushing metrics into it, but the central monitoring system is actually going to different targets and getting it. The two main components that do that, it's generally the service discovery and scraping part of Prometheus, and they go hand in hand, right? Service discovery is not something that's usually talked about, but this is the secret sauce to the match made in heaven between Prometheus and Kubernetes, right? So like, you can point your service discovery to your Kubernetes servers and tell it, hey, this is where you're gonna look all the workloads, this is where you're gonna look all the pods, all the things that I want you to monitor. Kubernetes will tell you, and then you'll find them, and then you suddenly go ahead and fetch the metrics from it. It almost feels like magic to a certain extent, right? Once your targets are discovered, the scraping service will go ahead and grab all the different metrics from it. It's very simple. It's position format. It's text-based. That was by design. Anyone can read it. You can query your metrics directly from there, look at them, understand what is going on very, 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 very easily. Once the metrics are fetched, we store them in the TSDB, or time series database for short, right? In a very efficient and compact manner using a technique called Gorilla compression in order to not store full data, just as a subset of it, and being able to deconstruct it later at query time. Once that happens, that's when the real magic begins, right? You can then define your powerful alerting rules that help you call problems early before your users even notice. This rule can be as simple or complex as you want them to be, right? You can say, hey, alert me if the temperature of my room reaches 34°C for more than 5 minutes, which is very straightforward. But you can also get much more advanced using things like linear prediction in order to forecast whenever this queue will run full in 30 minutes. Predicted linear is probably my favorite function in Prometheus. The first time I saw it, it just blew my mind. And I've actually seen that alert fire, and it's actually been true. It's just incredible when you're able to do things like that, right? Being able to see a problem before it actually happened. Cool. On top of that, you can build alerts to tell you that, right? Like, that's what it's for. And build your beautiful dashboards using PromQL from there, right? Like, we've all heard of Grafana. I'm not even going to touch on that, right? But that's kind of like the secret sauce on top. Your dashboards can show anything from system load to request latency to memory usage to business level metrics like conversion rates or sign-up trends. At the end of the day, you can think of this as your control panel for your entire infrastructure when you have all the different pieces of the puzzle set up. So whenever it's alerting, forecasting, or visualizing, once your metrics are in the systems, like the possibilities are completely endless, right? Great. So that covers pretty much all the basics that we have for Prometheus, but I want to show you, what's exciting, what's new, and why we decided to finally, after so many years, create a new version of Prometheus, right? This is a slide to show you like the different versions that we have released this year, all the way from 3.0 to 3.5. We also have a long-term release, which is meant to be for people that want the stability but don't necessarily want the new features. So if you want to keep the same version of Prometheus running for years to come, we have the LTS version in order to do that. Too many exporter objects to list, and we had a new version of the alert manager in the meantime. Cool, this is the thing that I was talking about. That slide was there to remind me to talk about the new versions. So yeah, we did a complete revamp of the UI. Everything that you see, every single page is built from the ground up. It's now using React, and now the pages have been revamped from the targets page to the alert managers page to the rule page. All of them, you can see it with a whole new design, much more slick, much more snappy, much faster. But if you ask me, what's the key factor that you put in new, what's the key thing that we put in the new UI, it's the query explainer. So now we have what we call the explain, which is powered by PromLens. A huge step in trying to make PromQL a little bit more approachable, which is one of the things that I struggled the most when I started learning, when I started using Prometheus. When you run a query to the explainer, it will break down each part of your expression, and it will tell you exactly what it's doing. I'll be honest, when I first started learning PromQL, I really struggled to understand how my queries worked, especially when they got a little bit more complex, when you had different joins, when you have different group bys, and I didn't really understand, so how does this model work? So now with explain, it's like there's no guesswork, right? It's like you can just tell it, hey, can you break down this query for me? And it will show you what every single part of the query is doing, and you'll be able to understand exactly what's happening. But like, if you think about this is not just some sort of like static analysis that's telling you, hey, your query is malformed, or here's how this query should work. No. This is actually interacting with your data, right? So like, this is actually telling you, based on the data that you have and the query that you're giving me, these are the results that I'm going to output at the end of the day. And I think this is just brilliant, right? It's like, it's not some generic message that you're getting. You're actually getting something tailored for the data that you are trying to query. And here's an example of that, right? Where you can see that I put some labels over there. It's telling me, the reason why we wouldn't be able to fetch your query is because you have too many labels that match on the other side. Cool. Moving on, I want to touch a little bit of on native histograms. For those of you that have used it in the past as a way to measure latency, you know that the power they carry. I'm not going to bore you with all that. They give you a really good way to determine whenever an API endpoint is slow, and with exemplars, you can pinpoint exactly why is it slow, right, on the general sense. The only downside to that, to using histograms as a whole, was it was way involved for you to define your buckets of data, right? So like, where does this data that I'm going to measure fall down? It's like, is it seconds, is it milliseconds? And if you were too wide or too narrow, you wouldn't get the data accuracy that you needed at runtime, right? So it would require a little bit more of play in order to be able to define the buckets. So instead, we brought the whole new thing on the block, which is the native histograms, which gives you an incredible resolutions within the values that you can be observed, right? Illustrated here are some of the options that you can set, but these are not important and too complicated for me to explain right now. So I don't want to look at this code anymore, and I want to look at exactly what happened. It's like, this is the thing, right? Like, look at this distribution over time that you see here, and assume that it's latency for the sake of argument, right? Here, this tells you that most of the hits are around these three areas, right? And then everything else is not necessarily being hit too much, right? And you're able to say, yeah, well, 0.1, 0.25, 0.005 is like, those are the hot areas of my API. And depending on your buckets, you might be satisfied with this answer, but your users will tell you something else and tell you, I'm not really seeing the same thing that you're seeing. And with native histograms, it's like they tell a completely different story, right? Like before, stuff that was previously hidden with the old histograms is now you can see it very clearly with the native histograms, right? Now we can actually say, no. Like the actual hot path of this API tells us that most of the latency is actually 0.0625, right? Which was a number that was completely lost between 0.1 and 0.25, right? I think this is just magical, right? Like native histograms have changed the game on all senses of the word, and I think this is something that was worth declaring Prometheus 3.0 for, right? The other cool thing, and something that I'm very, very vested about, it's remote write. It was one of the first features that I actually worked with in Prometheus. I remember joining Grafana, and Tom, who's their CTO, now telling me, it's like, hey, here's this Prometheus thing. You're not going to add metadata to the spec that we have been using in order to do the remote write. And I'm like, what? What's going on? Never had a monitoring background, never dealt with Prometheus before. And it was quite something to be able to understand how this protocol and all the magic that was behind it, right? The thing was that remote write has remained unchanged for almost 7 years. And given the important aspect of Prometheus that it is, it's almost amazing that it got us this far in the way that it is today, right? Prometheus is pool-based for a reason, and I want to make that very clear, right? We want to have the performance and reliability that deserves a monitoring system by pulling data that we consider, and pulling data is what we can actually consider the right thing. However, we actually understood the message loud and clear from the users in the community that getting your data out of Prometheus to a protocol or a database that might be push-based, it's something that the community wants, and they want it to be done reliably, and they want it to be done efficiently. So we, started putting our engines to work and our minds to work in order to try and optimize for that, right? So over the years, we have observed an influx of projects, such as like Cortex, Thanos, Mimir, and other Prometheus-compatible backends be built around Prometheus, right? And no, I completely understand the Prometheus Federation is not the solution for these systems, right? It's like they want it to be push-based. And with Prometheus 3.0, we have completely overhauled the remote write specification, right? And we're releasing remote write 2.0 with Prometheus 3.0, and I want to show you exactly how we did that and what is this new version of the protocol, right? So here we have two separate labels, same metric, different labels, different values. On the message formats, you can see that the labels are basically specified twice, and some of them are pretty similar, right? So you have the name, you have the same metric value, you have code as a label, even though it has a different value, right? And as you might expect, it's like you have a lot of data duplication here, and I think we can definitely do better. And that's basically what we did, right? Like we use a technique called string interning, and it's pretty similar to what we use within the TSDB internals when we call it a symbol table. So by defining values once and then referencing the original value just once within the actual metric label, we have been able to optimize in order to save a lot of space and optimize for compression as well, so this compress a lot better. And as a result, we have some really big changes, right? It's like you can see a bunch of improvements around messages sent on the wire, so this is less for your egress cost of your build, so your internal transfer. You have less bytes that are allocated. That means save CPU usage, and as a result of the top, you can see the bottom how much CPU we're saving on the new version of that. The more samples you send, then the bigger the gains. These numbers are quite impressive for a change that's so simple at the end of the day. It's important to note that the changes that you see here, so the improvements that you see here, are with the new features included, right? So like we're actually talking about sending native histograms, sending metadata, right? So like these numbers as a whole, they don't tell the full picture. That's why you see when in here it says plus features, right? So like before you would have to enable these features, whereas in remote write 2.0, the gains were so effective that we now just turn it on by default at the end of the day, because it was consuming much less. So now you no longer need to play around with, should I enable this, should I not? It's like, this is all the goodies for free in the protocol itself. Cool. This is a big topic, Prometheus and Auto, right? we have been working with OpenTelemetry for a while now, and it's certainly been a long road. There are many things that we had to do over the year, but with Prometheus 3.0, we fully support the OTLP protocol. Even though Prometheus originated, as I said before, with the strong roots in pull-based monitoring, we also understand the need of users to be able to use the OTel and the collector on their gateways and be able to push their metrics into Prometheus. So now that's something that you can actually do directly, right? And the community has the flexibility now to be able to use push or pull in whichever cases you want. I gotta be honest here, as I said, I'm still a big fan of the pull-based method for many reasons, such as like better reliability, cohesion between components. But if you prefer the other way around, you can certainly do that with OTLP or with Prometheus Remote, right? More OTel here. This is the dots problem, no, this is actually the resource attribute, sorry. Resource attributes being able, before when we first implemented this, we used to have a dedicated metrics for the resource attributes and they would not get attached to the metrics directly. We heard the message on that one as well. People wanted to have their resource attributes on OpenTelemetry protocol be attached to the metric itself. So now you can also define that, right? So like you can say which are the resource attributes that you want to have promoted. So just like in this example, you have server address. When you query the metric here directly, you can actually see that we have server address attached as one of the labels directly into the metric. We no longer need to do those really complicated joins that we used to do before in order to get the same metric in the same place, right? You can also note that dots are there. There were a really big contention on whenever we could use dots. Prometheus originally did not support using dots within the metrics name. And now you can. Don't forget the quote though, because that's something that you need. We're looking for feedback whenever this is something, the quotes is something that actually bothers you, because there are some cases that we could actually remove them for, but we prefer to be safe than sorry. All right, it's like, that's very well ingrained within Prometheus since the promise that we made a decade ago that nothing would break, and we try to keep it as much as possible. True to that promise. It's like more on the exposition format, right? The problem of dots that I just talked about, it looks like something that it's very, very, very simple, right? But I can't overstate how much work this was. It might look extremely simplistic on the outside, but the key and I will realize that there's a lot happening under the hood to make it possible. A colleague of mine named Owen Williams did a brilliant talk going through the intricacies of adding supports for the dots or any UTF-8 character, and he named the talk "Why Not Just Dots," which was presented at PromCom 2024 last year. I think it's brilliant. So you want to understand more about this problem, what it took so long to implement, what was the controversy around it. You can watch the talk. It's really condensed into a 30-minute format, so you'll be able to understand everything that's going on. I think it's just a great watch. What else from this slide? Oh, cool, yeah, PromCon. PromCon is happening this year. We actually opened the CFP 4 days ago, so you can go to the website or Google promcom.io and it'll show up immediately. It's happening in Munich. It's being organized by Grafana Labs, which has been a long time since that. And yeah, it's my favorite conference of the whole year. We keep it very casual. It's a community conference. It's for the people, extremely close. It's great if you want to get closer to the community as well. So I suggest you try and look that up. Cool. What else? There's more things for OpenTelemetry that we have coming soon that we haven't finished just yet. So the inclusion of the created at timestamp and supporting delta temporality within OTel as well. These are two things that we have that are coming soon. And yeah, you can follow along their progresses on the link over there in order to know when will they be ready. Because I know some of them are already in experimental support within Prometheus. How am I doing for time? Oh, wow. Okay, I have only 5 minutes left. Okay, so that covers the basics of Prometheus. I'm going to talk briefly about the governance. This is a story about how I became a team member. So, as you know, I was known as the alerting guy. I made a very crazy decision, which is to replace the replication protocol of the alert manager for our internal cloud service. So I use what we call a dedicated hash ring in order to be able to communicate between instances and add horizontal support to the alert manager, which is something that wasn't possible. I put it in Mimir, and I did a bunch of contribution upstreams as part of that, right? Eventually, someone sent me an email. It's like, hey, you want to join the Prometheus team? And I'm like, okay, cool. This seems like a cool bunch. I kind of want to do that. That is a problem. It's like, moving forward, that's not the way that we want to invite people at the end of the day. My really cool generated AI image. This governance has been active since 2018. They've served us really well so far, but it's like, this is not the way that we want to add people, right? It's like, we want to have a bunch of individuals from very diverse backgrounds. That's kind of the goal. And seeing people that are contributing around, not having a clear path to maintainership is not something that we want, right? So like, this is how the government works right now. It's like, there's no consensus. The consensus is done by lazy consensus, so as long as the majority doesn't vote against it, something immediately passes. Once you become a team member, you have access to everything. So I have access to, the Twitter accounts, full access on GitHub. I can bring down the Prometheus organization tomorrow. Right? It's like, you need to be able to give this permission to high trust individuals at the moment they become a maintainer. And that's kind of a problem, right? Like, we don't want to do that from the get-go. Yeah, it's like, team members need to be active for at least 3 months, and then usually someone votes you in and tells you, hey, this is how it goes. But there's no clear path to maintainership, right? Like, there's a hesitation to add new members, there's no role, there's no organization. There's an overrepresentation in the projects by Grafana Labs, and we have recognized all of this and others, which you can read about over there. So our goal is to go from 30 to 300 diverse individuals. Sorry, I'm blazing through this because I know I don't have time. This is the proposal for the new government. So we're going to have 3 different roles and 1 steering committee. Contributors, anyone who has contributed to Prometheus. Members need 20 contributions over 12 months, and this is supposed to be really low bar. A contribution is a comment, a meetup count, a blog post count, anything, and then then that leads you to a path of maintainership. Maintainerships are already defined within the existing project, so this is something that the maintainers of that project would be able to vote on directly without necessarily being a Prometheus team member and having full access to everything, right? It's like, the steering committee will be defined by a members vote, and it will be based on 2 years term. And this would only be 7 individuals within the whole Prometheus organization that get to be part of the committee that it's voted directly by every single member that's there. Yeah, we need help. We need you. Every single one of these projects, the SDK, the alert manager, the servers, doing triage issues, is like, it's like, this is what we want. We want people contributing. We want them to feel part of the community, and this is what the government is meant to try and solve. Sorry, I had to run through that. I think that's it. I think we have 1 minute left. I can maybe take a question.
Is there any plan for the Prometheus project to build an MCP server?
Oh, that's a good question. So the question was, is there any plans for the Prometheus project to build an MCP server service? I'm not sure, in all honesty. I'm not sure. I don't think that has been discussed.
I'm one of the Prometheus maintainers as well. I want to do this. I want to enable Prometheus and I'm one of the Prometheus maintainers as well. I want to do this as a mentorship project in CNCF. Oh, there's no concrete plans, but we want to.
Okay, cool. Yeah, I really look forward, because the Argo project just had an MCP server. Okay, I would really look forward to that, because the Argo project just launched their MCP server. So it's just really cool to have MCP server so people can use it to build AI agents very easily.
Oh. That's it. Okay, yeah, I think that's it. Thank you.